Hello student, in the last lecture we have seen that the derivatives of some standard functions. So first is power function, then constant function, trigonometric functions, exponential functions and logarithmic functions. Suppose in general here we write the derivative of these function in a table. Suppose function is y, then its derivative is dy by dx. Whenever our function is f of x, then its derivative is f dash x. So first function is a constant function, its derivative is 0. The second function is x raised to n power function, then its derivative is here n into x raised to n minus 1. Third function is a trigonometric function. Write down derivative of root x is 1 by 2 root x. Fourth, derivative of 1 by x. 1 by x or 1 by x raised to n here. So it is minus n upon x raised to n. Then our function, we take trigonometric functions. First trigonometric function, derivative of sin x is cos x here. And 6, derivative of cos x is minus sin x. Derivative of tan x is sec square x. Derivative of sec x, it is sec x into tan x. Derivative of cot x, it is minus cosec square x. Derivative of logarithmic functions or exponential logarithmic function log x, it is 1 by x. Then derivative of exponential function a raised to x into log a, and derivative of e raised to x exponential function is e raised to x. So these are the some standard functions whose derivative are given here. Yes, there is a table. Now, by using this derivative of standard functions, we find the derivative of function in next question. But in this exercise 9.1, in first question, find the derivative of the following functions with respect to x by using method of first principle. By using method of first principle means actually we have to find the derivative of given function by using the definition of the derivative, means f dash x. First principle is f dash x equal to limit of f of x plus h minus f of x upon h as limit as h tends to 0. So when we find the derivative of the given function by using first principle, we consider, let this function f of x square plus 3x minus 1. Then we take where there is x we put here x plus h. Where there is x we put x plus h in each x. So here it is x plus h whole square plus 3 into x plus h minus 1. Take its expansion like a plus b whole square. So x square plus 2hx plus h square. This is the expansion of x plus h whole square. Plus 3 into x, 3x plus 3h minus 1. So this is the f of x plus h function, value of f of x plus h function. Now by first principle, so f dash x is equal to limit as s tends to 0 function f of x plus h minus function f of x upon h. So now we substitute the value of this function f of x plus h and f of x. F of x plus, the value of f of x plus h is here, x square plus 2hx plus h square plus 3x plus 3h minus 1, and then minus value of fx is x square plus 3x. So due to this minus sign, this plus x square is minus x square, and then this plus is minus, and this minus 1 is plus 1, whole divided by h here. And so therefore limit as s tends to 0, here plus x square and minus x square will get cancelled. This plus 1 and minus 1 also will get cancelled. Then here this plus 3x and minus 3x also cancel. So remaining terms are here. So h square plus 2hx plus 3h, and yes, these are the remaining terms. Now we will take common h from the numerator here. So in this side, so f dash x equal to, so this limit as s tends to 0, we take common h from the numerator here, h in bracket h plus, we take common h here, h plus 2x and plus 3 only divided by h here, this. Now this h will get cancelled, and remaining terms h plus 2x plus 3, and then apply limit as h tends to 0. So therefore here it is 0 plus 2x plus 3 only, and so it is 2x plus 3. So this is the derivative, which is the derivative of x square plus 3x minus 1. Hence we have to find the derivative of this function. Derivative of this function x square plus 3x minus 1 is 2x plus 3. Now we will take next, then second function sin 3x. So we have to find the derivative of sin 3x by using first principle. Again, let function f of x equal to sin 3x. Its main basic function sin x, we have to already find the derivative of the sin x by using the first principle. So here there is only 3x here angle. So put where there is x plus h, it is sine of 3 into x plus h. So that is sine 3x plus 3h, f of x plus h. Then by first principle, f dash x equal to limit of f of x plus h minus f of x upon h as h tends to 0 is equal to, substitute the value of this function f of x plus h. It is sine of 3x plus 3h minus f of x is sine 3x divided by h at limit as h tends to 0. Here we use addition formula, sin a minus sin b. It is a 2 cos of a plus b. A means this 3x plus 3h and b means 3x. So a plus b means 3x plus 3h plus 3x by 2 into sine of a minus b. A means here 3x plus 3h minus 3x, b means by 2. So this is the expansion of sin a minus sin b, whole divided by h here. Now here 3x plus 3x, it is 6x by 2 and 3h by 2, and here plus 3x minus 3x will get cancelled, it is only 3h by 2. So use f dash x is equal to, limit as it tends to 0, 2 cos of 6x plus 3h by 2 into sine of 3h by 2 whole divided by h. Next step, limit as h tends to 0, 2 cos of, take this 2 in the side, 2 cos of 6 by 2, it is 3x plus 3h by 2 into, take the limit separately to each function, limit of sine of 3h by 2 upon h. Due to this multiplication sign, we take this h in the denominator by this sine function. So we adjust here, because the sine of, since the angle of sine is 3h by 2, we adjust here in the denominator here 3h by 2. So we multiply and divide 3 by 2, 3 by 2. So 2 will get cancelled, and so therefore it is only 3 constant here. Take this before this limit. Here limit, apply limit as it tends to 0. Here limit of sine theta upon theta, it is 1. So apply limit here. So it is a cos of 3x plus, it is here it is the h tends to 0, therefore it is 0 into the value of this limit of sine theta upon theta, it is 1. Since limit of sine theta upon theta as theta tends to 0, it is 1, and so therefore it is 3 cos 3x only. So the derivative of this sine 3x is 3 cos 3x here, m dash x. So now we will take next example. Now the next example, e raised to 2x plus 1 exponential function. So we have to already take its basic function exponential function, e raised to x. Derivative of e raised to x is e raised to x. Here e raised to 2x plus e raised to 2x plus h plus 1. Where there is x, we put here x plus. Then f of x plus h equal to e raised to 2 into x, it is 2x plus 2h plus 1. Now by first principle, f dash x equal to limit of f of x plus h minus f of x upon h as h tends to 0. We put the value of this function f of x plus h is e raised to 2x plus 2h plus 1 minus e raised to fx is e raised to 2x plus 1 whole divided by h. Then we take common here e raised to 2x plus 1 here. When we take common e raised to 2x plus 1, it remains only e raised to 2h here, minus here it is 1 because we take this term common, divided by h only. Now we take this term before the limit. Therefore f dash x equal to e raised to 2x plus 1 into limit as h tends to 0 e raised to 2h minus 1 upon h here. Now we add this here, the power of exponential function e. Here it is power is 2h, but here it is 2h only, that's why we multiply and divide by 2, and so therefore we apply limit to this function. So e raised to 2x plus 1 is constant as it is, into its value is 1 into this 2. So therefore, because this limit of exponential function e raised to x minus 1 upon x as x tends to 0, it gives 1, because it gives log e, but log e is 1 here. So therefore, this into 1 into this 2, so it is 2 into e raised to 2x plus 1. So the derivative of this e raised to 2x plus 1 is here, e raised to 2x plus 1 into derivative of 2x plus 1. Derivative of 2x is 2 and derivative of constant 1 is 0. That's why it is 2 into e raised to 2x plus 1 is the derivative of this e raised to x plus 1. Now the next d 3 raised to x, it is also exponential function. So let this function f of x is 3 raised to x, then we put here f of x plus h, where there is x we put x plus h, and so therefore by first principle f dash x equal to limit of f of x plus h minus f of x upon h as is equal to 0. Put the value of f of x plus h is here 3 to the power x plus h minus fx is here 3 raised to x upon h. Again we take common 3 raised to x here. When we take common 3 raised to x, it remains 3 raised to h only and minus 1 whole divided by h here. Now 3 raised to x take before this limit. So therefore f dash x equal to limit, or it is a 3 raised to x into limit as h tends to 0, 3 raised to h minus 1 upon h. So it gives, and apply limit this, the value of this is a log 3 here, log 3. Since limit of a raised to x minus 1 upon x as x tends to 0, it gives log e, exponential function. So that's why it is a 3 raised to h minus 1 upon h as x tends to 0, it gives log 3. And so the derivative of this 3 raised to x is 3 raised to x into log 3. Hence, we have find. Then next function, it is a logarithmic function. We find the derivative of this logarithmic function by using first principle here. So our function, let fx is log of 2x plus 5. We have already find the derivative of basic function log x, it is 1 by x. Same way its derivative is here 1 by 2x plus 5 into derivative of 2x plus 5 is 2 upon 2x plus 5. So f of x plus h. Then f of x plus h, it is a log of 2 into, here it is x, we put x plus h plus 5. So it gives log of 2x plus 2h plus 5. So it is f of x plus h. Now by first principle, f dash x equal to limit of f of x plus h minus f of x upon h as h tends to 0. So substitute the value of these two functions. So the value of this function is log of 2x plus 2h plus 5 minus fx is log of 2x plus 5 whole divided by h. Now here we use logarithmic rule, log a minus log b, it gives log of a by b. Suppose this a and this bracket is b, so it is log a minus log b, it is log of a by b. So therefore we write in this way, log of a by b, 2x plus 2h plus 5 divided by 2x plus 5 and whole divided by h here. So therefore f dash x equal to limit as it tends to 0. So here we take this 5 here and this 2h in here. So that's why it is log of log of 2x plus 5 plus 2h divided by 2x plus 5. So therefore limit as it tends to 0 log of, we divide these two terms by separately, so same term, that's why it is 1 plus 2h by 2x plus 5. We divide each terms by 2x plus 5. Then we take log of 1 plus x. Yes, so here we adjust this log of 1 plus 2h by 2x plus, it is whole divided by h here, this h whole divided by h. So therefore here this 1 plus 2h upon 2x plus 5 divided by h this. So we adjust this h. So here also we multiply and divide, adjust 2 upon 2x plus 5 into we divide and multiply these two terms, 2 upon 2x plus 5, 2 upon 2x plus 5. So we adjust here because here is only h, that's why we adjust this. So therefore we apply limit as h tends to 0 to this term, and this will be constant term. So limit of a constant is same constant. So therefore its value is here. Because we use here this formula, limit of log of 1 plus x upon x, limit as x tends to 0, it gives 1 as x tends to 0 here, since we use this formula. And so by using this formula its value is here, because 1 plus x upon x, limit as x tends to 0, x tends to 0. So therefore its value is 1 into 2 upon 2x plus 5, and so therefore f dash x equal to only 2 upon 2x plus 5. It is the derivative of this logarithmic function log of 2x plus 5. Hence we have find. Now the next function x root x. Before this example number f and g, these are tan and these sin of. So we have to already take its basic functions. That's why you may try to solve this at home. Now we take last example, x root x. Here function let fx is equal to x root x. So we write this function x root x in this way, x to the power x into the value of root is 1 by 2. So whenever in the base there is a product and same terms, and then add the power. Means here x to the power 1, its power is 1 plus 1 by 2, and so it is x raised to power 3 by 2, x raised to power 3 by 2. So same way we put where this x is x plus h into under root x plus h. Okay, also we write this function in this way, x plus h to the power 3 by 2. And so therefore by first principle, again limit of f dash x equal to limit of f of x plus h minus fx upon h. We substitute the value of this both function. So f of x plus h is here x plus h to the power 3 by 2 minus fx is x to the power 3 by 2 whole divided by h. Now due to these functions, actually this function is a rational function, that's why we rationalizing this function, rationalizing the numerator here. So therefore the numerator is x plus h raised to power 3 by 2 minus x raised to power 3 by 2 divided by h into, we rationalize the numerator. Here it is minus, we take plus divided by x plus h raised to power 3 by 2 plus x raised to power 3 by 2. Okay, then multiply numerator and denominator into denominator here. When we multiply this here, this x plus h raised to power 3 by 2 into x plus h raised to 3 by 2, it gives only x plus h raised to power 3 only. So therefore f dash x equal to limit as h tends to 0. So x plus h raised to power 3, and same way again x raised to 3 by 2 into x raised to 3 by 2, it is x raised to 3 divided by h here into this term x plus h raised to power 3 by 2 plus x raised to power 3 by 2. So how it becomes 3 power of x plus h? So therefore here we check x plus h to the power 3 by 2 into x plus h to the power 3 by 2. Again here in the multiplication, whenever base are same, then add the power. So therefore x plus h whole raised to power 3 by 2 plus 3 by 2, and so x plus h to the power, here cross multiplication LCM here. So it is 4, 2 to the 4, 2 3 is 6 plus 6. So it is x plus h to the power 12 by 4, and so it is x plus h to the power 4 1 is 4, 4 3 is 12. So it is 3. Hence in this way multiplication of these two functions, these two brackets is x plus h to the power 3 only, and same way multiplication of this x into x to the power 3 by 2 into x to the power 3 by 2, it is x cube only. So now therefore we apply we take its expansion as h tends to 0. So expansion here we use this a plus b whole cube. We have already studied here a cube plus 3a square b plus 3a b square plus b cube here. Expansion of this by using this expansion here, x cube plus 3 x square h plus 3x h square and plus h cube. So this is the expansion minus this x cube as it is whole divided by h into this x plus h raised to power 3 by 2 plus x raised to 3 by 2, and therefore here this plus x cube and minus x cube will get cancelled. Now So remaining terms, from the remaining terms we take common here h here. So take this first term. When we take common h from this h cube, it is h square only, and from this second term it is 3x h only because it is h square, and the last term is 3x square divided by h into x plus h whole raised to 3 by 2 plus x to the power 3 by 2. Now this h will get cancelled, and therefore we apply limit separately. Limit as h tends to 0 in the numerator, h square plus 3xh plus 3x square divided by here limit as x plus h to the power 3 by 2 as h tends to 0 plus limit as x tends to power 3 by 2 as h tends to 0, and so therefore here it is h, that's why it becomes 0. This term also 0, h is here, but this term is not 0 because there is absent h. So that's why in the denominator 0 plus 0 plus 3x square only in the numerator here, and in the denominator here it is x plus 0 raised to 3 by 2, means it is only x to the power 3 by 2 plus it is a constant, there is absent h, that's why it is only x to the power 3 by 2, and so it is 3x square divided by 3x square divided by x raised to power 3 by 2 plus x, it is 2x raised to 3 by 2, and therefore it is 3 by 2 into x to the power x square. Take this x to the power 3 by 2 in the numerator, that's why it becomes x to the power minus 3 by 2, and so therefore it gives 3 by 2 into x to the power. Here again base are same in the product, so therefore add the means 2 minus 3 by 2, it gives 3 by 2 into x to the power 2 to the 4, 4 minus 1, 4 minus 3, it is 1 by 2, and so finally, but the 1 by 2 is the value of root, so therefore 3 by 2 into, right here also root x, because the 1 by 2 is the value of root, so this is the derivative of the function x root x. Only the derivative of root x is 1 by 2 root x, but here it is x into root x, that's why its derivative is 3 by 2 into root x. Hence we complete this first question of exercise 9.1. So today we will stop here.